I'm Kris Brandow. I'm a senior engineer at MongoDB. You can find me on the internet at Scriptable, pretty much anywhere and everywhere. I'm going to do a quick run through what we're going to talk about today. So there's kind of like 6 parts to this talk. We're going to start out with an introduction to the driver, basically where you can get it, what versions of Go it supports, what versions of MongoDB it supports, and just like a little hello world application. Then we're going to get into kind of the meat of this talk, which is 5 key features about the database, or about the Go driver. Those are how to create a Mongo client, which is the thing you use to actually interact with the database, how our options are designed for configuring different collection methods and the client itself, the difference between encoding and decoding BSON with structs versus kind of our own handlers that you can use, how to properly shut down a Mongo client when you're done with it, and finally, how to use our high-performance BSON library. So that said, who am I? What do I do? Why me? I'm a senior engineer on the Go driver, as Michelle said. I am also a writer and runner, and most importantly for this talk, a baker. Here's a nice picture of some cinnamon rolls I made not too long ago. Few key warnings before we get started with the actual introduction to the driver. The driver is still very alpha, so the APIs in this talk may change over time. So don't be, you've been warned that things will probably change before we go stable. And the next warning is that there's a lot of baking content in this talk. So we have a cookie policy here. I have actually baked enough cookies for everyone in the crowd. And I have my 2 interns back there, Divja and Roland, who will hand out cookies while we go through this talk. So, Go driver basics. How do we get started with this thing? So you can get it on GitHub at this URL, github.com, MongoDB /Mongo Go driver. We support the most 2 recent versions of Go, so the 2 supported ones. So as of today, that's Go 1.9 and 1.10. Come August, that will be 1.10 and 1.11. You can probably still compile on 1.7 and 1.8, but we don't guarantee compatibility with those versions. We support the latest 3-ish, I guess 4 now, versions of MongoDB. So we support 3.2, 3.4, and 3.6. As of today, we don't have the full feature set for all of these versions, but we will in the coming months. And we do alpha releases every other Thursday. So there will be a release coming out tomorrow, Alpha 8. So you can download that and play around with it if you like. OK, so we're going to go through a basic hello world application here. So the very first thing you do once you've imported the Mongo package is you call this mongo.connect function. And what this will do is it will kind of instantiate a client for you and then actually connect it to the database, start monitoring, inspect your cluster, figure out how many nodes you have, if you're a replica set or a sharded cluster, or anything like that. The next thing you do is you get a database and a collection. In this example, we're getting the database drivers and the collection Go from that. And then finally, you can do something like insert a document here. And there's 2 important components of this function here that I want to point out. The first is that we're using context background here. You should just never do this. Like, don't use a background context. Please always use a timeout when you're using a context. This will make sure that you don't kind of wait forever for the network or something like that. Back to the main example. Right here, we're using the new BSON library that we have. It's a little verbose, so if you like, you can just use map. So this is a basic map string interface, and we'll turn that into BSON for you, or you can use just regular struct. This is like a hello struct with the value MongoDB World 2018. So now we've gotten through that, we're going to get into the meat of this talk, which is the design of these 5 key features I want to talk about. To talk about these, we are going to use analogies to baking. So these are the analogies. We're going to talk about eggs, leavening agents, baking from mix versus scratch, the importance of cooling your baked goods, and measuring by volume versus weight. And each of these has an analogous thing in the Go driver that it describes. So the first one, we're going to talk about the Mongo client, and we're going to talk about eggs. So an egg is a very interesting ingredient in baking. It's this nice little binding agent, leavening agent that comes kind of bundled together, but it's easily separable. So here we have an opened egg. It has a yolk. It has an egg white. We can split the egg yolk and the egg white apart, and we can use them for different things. So egg yolks are generally good for adding creaminess to your recipe. They provide structure in baked goods. You can use them as a leavening agent, like in certain cakes where you just beat them with sugar. And here's a satisfying GIF of beating some egg yolks. And then there's egg whites. And egg whites provide structure on their own. They can be used as a binding agent for things like marshmallow cream. They can add structure to a cake. They're the main ingredient in things like meringues. And here's another satisfying GIF of beating egg whites. And then finally, this thing about being able to separate an egg. You can kind of open an egg, separate it, and then throw it back in the bowl. And you've kind of gotten back to where you're starting. So why am I talking about eggs like this? There are three kind of different functions you can use when you want to spin up and connect to MongoDB deployment using the Go driver. The first one's new client, which will just hand you back a new client. The second one's connect, which will actually spin up some network sockets and some Go routines for you. And the third one is the connect function we saw before, which just does basically the first two things combined. So when you do this, this is probably what most people use most of the time. Probably 90% of you in the room will do this. You just do mongo.connect, you give it a context, you give it a connection string, and boom, you're connected, you're ready to go. This has spun up several Go routines. It's monitoring your cluster. It knows everything that's going on. But if you, say, want to just instantiate objects, and you don't want to do network connections right out of the bat, and you really just want to start doing, hey, I want to make an object, don't do any Go routines, don't do any network sockets, don't do anything behind the scenes. You can just call a new client. And that will instantiate the object, make sure your connection string is valid, make sure that everything's set up and ready to go for you except for the actual connection part. And this is kind of like just using the egg yolk in a recipe, right? You might be using an egg white again later, but for now it's like, okay, I'm just doing my beginning mixing in. And then following that, you can call connect. Connect will actually bootstrap and connect to the database, as I've said multiple times. And then you can kind of do these things next to each other, which is a lot like the, kind of I've split an egg, I've separated the egg yolk and the egg white, and I've put them in the bowl together, right? Probably shouldn't do this. Probably should just do connecting. All right, so that's kind of it on the kind of client and the Mongo client and the egg analogy, kind of splitting things up. Next, we're going to move on to one of my favorite topics, which is leavening agents. So first, I'm going to talk about options. So for anybody that might be confused, an option when I'm talking about it is just a parameter that's used to modify the result of a function or a method. So when you call a new client and you give it an app name, that's an option. If you call db.update and you give it upsert and say to upsert, that's an option. And our options have a composed design to them in the Go driver. They're composed of self-referential functions, variadic functions, which allow you to pass no options, and we use interfaces for type checking enforcement. So I'm going to go over these three things quickly. The first one is a design pattern I really like. So it's a good general Go configuration design pattern. I first read it in 2014 in Rob Pike's blog post here. But essentially what you're doing is you're making a type function, an option type, that's just a function that takes the thing you want to configure or modify. And in this case, we want to make a new foo, and we give it options. And all we're doing is we make a new foo pointer, and we pass it in. And each function knows what it needs to do to that foo object to manipulate it or change it in a way. And here's an example of that. This is going to set the verbosity level on foo. It just takes an integer, it returns you an option that you can pass in later. You might be wondering, why would you want to use this pattern? It's mostly good for more complex things where you don't want to pass in an entire struct, right? You want to pass in, or you don't want to pass in a struct that has multiple parameters that might need to be configured in a specific way. This allows you to kind of bundle everything under the hood. It allows you to change things later, which is really nice. In the actual Go driver, we don't actually define a type func, like an option func. We actually make an interface, so it looks just like this, and we have tons of them. The next thing we have is variadic methods and functions. This allows you to, if you don't actually need to pass in any options or parameters or configure anything, you can just pass nothing in at all. And the final thing is that we have type checking enforcement. So this is kind of like the whole composition of what our options look like in the driver. You have a type, in this case it's an int, and then you have this option method that gets called, and you get passed a foo, and you set verbosity, just like in our other example we had. So that's kind of the basics of how options work in the Go driver. Now we're going to talk about the baking analogy. So leavening agents are these things that allow your baked goods to rise. And if you want them to rise a lot, you'll use something like yeast. If you want them to rise a little bit, you can use something like baking powder, baking soda, egg whites, egg yolks. Usually you'll use something like yeast in bread, and you'll use things like baking powder and baking soda in quick breads. Think muffins, cupcakes, cookies, that kind of stuff. So when a baker starts out baking, they usually start with baking powder. It's the easiest thing, it's the simplest thing to kind of get stuff leavened. And then eventually, you'll start moving on to different kinds of leaveners, like baking soda. For anybody that doesn't know, baking soda is about 3 times as powerful as baking powder, so you can buy a lot less of it and get a lot more out of it. And then eventually, you might actually start using these two things together. So we're kind of using that as an analogy of how we expect people to use options within the Go driver. So we have these types that are called option bundles that I'll describe in a second that we use for discovery. So if you just don't know how the driver works and you're kind of just getting started, you haven't used MongoDB a lot, this makes it a lot easier for you to figure out what's actually a valid option for something. Next, we have baking soda, which is a little more advanced, and that's when you have option functions, which I'll also describe later, which kind of removes extra allocations you get from bundles. Thirdly, we have kind of using baking powder and baking soda together, which is like using multiple bundles and functions, which I expect people would use in a production application. And then finally, if you don't actually need to leaven something, if you're making shortbread cookies, for instance, that don't have a leavener in them, you don't take some like non-leavening leavening agent and throw it into your recipe. You just don't add anything. And that's why we have the variadic functions I mentioned before. So let's say that you're getting started with the Go driver and you want to build an application and you're just doing a proof of concept. So at first, maybe you have some data inserted and you just want to get it. You don't care how much of it is. You don't care what the driver is doing underneath. You're like, just give me all of my data so I can do something with it. In this case, you wouldn't be passing in any options at all. You just call collection.find and you give it a filter, which could be like x is greater than 5. But if you do want to start doing something a little more advanced with your finds, let's say you want to limit. You say, OK, I want you to only return me the first 100 documents. Well, now you actually need to pass an actual option to the driver. So we have this really nice bundle here. And as the definition kind of implies, we have all these methods that are hanging off of the bundle. And each of these is a valid method for the valid option for the method that we're passing it in. So there's like a find bundle, there's a find one bundle, there's like an insert many, there's a bundle for each of these things. So when you're starting out, you can just kind of pass this option by just kind of typing as you go. So you import the package, use the package.bundle find, and then you can get dot, and your editor will say, here are all the options that are actually valid for this. This means that you don't have to jump back to the documentation page or GoDoc or something like that to actually figure out what all the valid options are. The next thing that you have, so let's say you've been using MongoDB for a while now, so you understand how the Go driver works, you understand how our options package works, and you're like, I don't want to keep having to make these bundles. This is like a little bit longer than I want. Bundles actually creating an object. I don't want to do all the extra stuff. I'm gonna kind of go lower level. In that case, we have functions that match the bundle methods we had before. And the functions just kind of live in the package. So while a bundle is an instance of a thing, so like the find package has a find bundle and a find one and replace and find one and update, there's just one function for each of the actual options. So even though some options might not be valid for some of the bundles, there's a function in the package because something will use that option. So in this case, let's say that we want to, we're trying to tweak the underlying way that the driver pulls batches of documents from the database, because maybe we have a network problem, maybe our batches are just really large and we don't want to take up that much memory. So we can just use this batch size function here. And similar to before, we just pass in the option, but this is obviously a bit shorter now, right? We're just saying, hey, I know I want a find option, and I know I want a batch size of 100, and that's it, I'm done. So now we're going to wind back a little bit. I want to talk about bundles a little more, and the kind of flexibility you get with them. So the 0 value in a bundle is useful. You can just kind of declare it, and even if it's nil, you can use it, as we've done here, right? We just made a bundle, haven't actually created or anything, and we just say, hey, batch size 100. The bundle find method that we had before, or function that we had before, that actually takes other either bundles or options. So you can actually encapsulate a number of different options in this bundle and just carry it around and pass it around your application. So in this case, we're making the same bundle as we were before. We're just adding it a batch size, and we can pass it to this collection.find or any number of ones we want. And what this allows you to do is kind of set up a way of doing defaults, configuration, and overrides in your application. And what I mean by that is you can kind of just stream your options like I have here, and we'll take the last one that has been set. So in this case, by default, we're saying, hey, if no one has given me a configuration via command line or a configuration file, I want you to always have the batch size as 1,000. Send me 1,000 documents back. But in this case, we have instead said, oh no, we actually want to override that. We know we have either network problems or memory problems. We only want to return 100 documents. So this batch size will actually override the first batch size. And then finally, you have overrides. And this override in particular is saying, no matter what, only ever return 10,000 documents. I don't care if there's 1 million documents in there or whatever. And in this case, there's no way for the user or someone upstream to kind of apply a configuration that would change that. So that's kind of it. I think that when people get to kind of building more and larger applications, this is going to be an easier way for people to do configuration of things like the Mongo client or just these find methods. I know I've done a lot of struct wrangling in my Go code before, and it's just not very pleasant. So I hope you guys kind of enjoy this. Next, we're going to move on to another favorite topic of mine, baking from mix versus baking from scratch. And this analogy talks about, it kind of compares itself to encoders and decoders. And when you think about encoders and decoders for this section, just think about them as things that convert from one thing to another. So in the case of an encoder, a Go type to a slice of bytes, or a decoder, a slice of bytes to a Go type, not as kind of like the round-trippable thing where it's like, oh, you can encode something and decode something. So kind of think of them separately. So the baking analogy. So there's a range of things you can buy at the store that will allow you to produce some sort of baked good. On the far spectrum, you have cookie mix. Cookie mix is easy. Pick up a box, add eggs and butter, you're good. But you can only really make cookies with this, right? You can't make cornbread with this or waffles. That'd be a little weird. So kind of moving further down the spectrum, we have kind of this baking mix. You can kind of substitute this with Bisquick if you'd like. And with this, you can make like a lot more than just cookies, say. You can make waffles or cornbread or biscuits or whatever. But you probably can't make bread with this. And moving a little further down the line, we have this thing called self-rising flour. This is like basically flour with some baking powder and salt mixed in. But it's in a specific quantity, which means that if you have a recipe that needs more baking powder or less baking powder, you either have to add the extra baking powder or you kind of have to use a different flour. So this is kind of like, hey, it's something I can use, it's something that's useful, I don't have to add it, but it's only useful in very specific circumstances. And then finally on the right, we have just regular all-purpose baking flour. Which is your typical thing. But if you want to bake cookies, you have to gather many, many more ingredients. The common thing among all of these, though, is that you always kind of have to bring your own eggs. And in this analogy, you can kind of think of eggs as your data. So like even with our BSON library and our encoders and decoders, you still have to give us something. We just don't like magically encode stuff and hand it back to you. So Encoders and decoders. So the basics of this is I'm going to go through a quick example with structs, which is the kind of basic way of doing some encoding. So we have a struct here, my struct. It has a property called foo, that's a string. I can instantiate this, and I can pass it to Marshall, and I will get some bytes at the end, and I can do something with those bytes. So this is just kind of the basic method. We'll reflect over my struct, figure out what it is, and encode it. There's some overriding you can do, where you can say, hey, for this section, I would like to actually do the encoding or the marshalling. So in this case, we have my struct again, but this time it has another value. Instead of a string, you have this my foo thing. And my foo is a type foo, and type foo is a property, has a property of bar, which is a string. But in this case, we kind of don't really want to use it that way. We just want to say, hey, whenever I want to marshal this, always use baz. Like, just always use the string baz. I don't want to use whatever it gave me. I know what I'm doing. So when you instantiate one of these structs here, as we have with here, we made my struct. We've given it the my foo sub, the property, instantiate that as well. When we pass this to Marshall, it will reflect over my struct, see my foo, and see that foo implements BSON marshaller, and then say, hey, you wanted to handle this. And it will hand it back to that Marshall BSON method that we had previously. And then this method will take over. So that's like a little bit better. You have a little bit more control. You can do things a little differently. And this comes in handy in some places. So let's say you have a struct that now has a time field in it. And you want to handle, let's say, the 0 time in a special way, or just you want to handle time zones in a different way or anything. It's a little more difficult though, because you can't just add a method to the time.time type. You would have to do this, right? You have to declare your own time.time type, and then add Marshall BSON to it, and then do whatever you'd like to do in there. I personally find this super infuriating. Like, I don't want to declare a standard library type as my own type. I think that is absolutely silly. The standard library has good types, and then it will also only work in my type, right? If I had another time.time somewhere else in my application, that one would get encoded as usual. So it doesn't work that well. So that said, we have a super brand new API that will probably change, and it's still in the design phase, but I think it's really awesome, so I want to tell everybody. We have this way of registering a codec. And a codec is a thing that for a particular type will handle the encoding and decoding of that value. And the function signature, or the method signatures look like this. It's just a type that can have properties if you want, but you say, hey, when you get to it, use this thing to encode and use this thing to decode. A quick example of that is here. We make this new thing called a registry. We make our new time codec, and then we use the reflection package to actually get the type of time.time. You don't necessarily have to do this. You could also just pass us time.time, and we would figure it out. And then you register the type. And now when you go through and you say, hey, I want to have my custom encoding on that time.time object, once we actually get here, we'll just, you just have to call this new method, new function, bson.marshal with registry, and you pass us the registry. And now when we actually go to encode that struct, we'll say, oh, this is a time type. Let me look up in that registry what that codec was. And it will use that. So now everything is peaceful again. Everybody's happy. I'm not declaring custom types and nonsense. And then finally what you can do is you can just have you can just implement Marshall BSON on the type proper itself, and then you can just encode time.time how you like. And kind of the reason why you would do this instead of the aforementioned encoder, or the aforementioned codec, is because that codec does apply to everything that uses that registry. So if you have a circumstance where I only want to have this struct's time handled in a specific way, this is probably a better way to do it than using a codec. OK. So next topic, we're going to talk about closing and cooling. So I want you to ponder this for a moment. Let's say that you are doing something where you have to shut down your client. And there could be some operations running. You're not really sure. You just want to disconnect it from the server. when you call close, like what's the state of the resources, right? Remember when we did connect, we have these Go routines running, we have these network sockets. Like, what does it mean after we've actually shut everything down? And we're going to kind of take a little detour to baking again. Cooling is an extremely important part of baking. The cookies that you all just had have a cooling process after they come out of the oven, right? You can't just like pull the tray of cookies out of the oven, put it in, and start eating them. You'll likely burn your mouth, but they also won't be like structured like a cookie. The cooling process actually finalizes the formation of the cookie. And the same is true of brownies to an even more degree. If you actually put your brownies in the oven too long and kind of bake them to the point where you'd actually want to eat them, you have overbaked them. You got to like pull them out of the oven and kind of let them cool for a little while and settle, and they'll finish baking once they're out of the oven. So this is similar to how we actually do disconnecting in the driver. So once again, we are at the point where we're trying to shut down our connection. We've done everything we need to do with it. We're done with it. And it's super important here that you never do this, right? Never call contacts to do here, and please never call contacts at background here. Always give this a timeout. And the reason for that is we will wait until all of your network activity is done before we will return from this if we don't get a signal from the context. So in our default, we do this kind of graceful shutdown. We'll say, oh, you have things running. We'll just kind of sit there and wait and let things kind of peter out. If the context is canceled, we'll just start aggressively closing network sockets. We'll just close things and return for you. So you can do this with a timeout. You can do this with a deadline. You can even just do a regular cancel. And these things all work kind of the same, more or less. So to answer that question that I posed to you like 2 minutes ago, when client.disconnect returns, it means that there are no Go routines running, and there is no network I/O happening. We've closed all sockets. We've shut down all Go routines associated with that client. We have cleaned up after ourselves, and your client is back in that initial state as if you had called new client. All right, so the final topic we have, I've titled Weighing Your BSON. So as you saw before, you can have a custom struct or map or whatever that you pass to us. And additionally, you can use our BSON document type, which provides a kind of ordered recursive map that was kind of designed for high speed and low allocation costs. The baking analogy we're using here is weighing by volume versus weight. So you can kind of think of us doing this reflection process as measuring by volume. And to properly measure by volume, you kind of have to like fluff the flour up, as the person's doing in this picture, kind of lightly shake it into a cup, and then kind of just smooth off the top with a straight edge. And this will yield you about 4 1/4 ounces of flour. If you do the scooping method, which you saw right there, you will wind up with somewhere between 5 1/4 and 6 1/2 ounces, which is like way more flour than you wanted. So anybody that actually wants to bake, like weighing your flour, super good idea. So we're going to kind of expand on the MyStruct type here to kind of give you an idea of what we're actually doing under the hood when we're measuring our structs by weight, or by volume, sorry. So we have a basic MyStruct here that has 3 fields, foo, bar, baz. They are all strings. And let's say we instantiate one, we want to call Marshall. When we're calling Marshall, for each struct, for each property that's in there, we're kind of doing that same like mixing up the flour, kind of putting it in the cup, leveling it off over and over and over again. And it's kind of a slow process, right? Because like you know that each one is a string type, right? You know it's string, you know its key is foo, but we're doing all of this work over and over and over again when we marshal, and we do that work over and over and over again when we unmarshal. So what you can actually do instead of this is you can use our BSON document and our BSON reader types for measuring by weight. So what this looks like is the Marshall BSON method I mentioned earlier. But here it's like, OK, we already know that our keys are going to be foo, bar, baz. So we don't need to use reflection to look at that. We don't need to kind of fluff up the flour. We know the values are strings, so we can just use our constructor here that always gives strings back. And this is kind of just like, taking flour out and kind of dumping it into a bowl on a scale and saying, I need 12 ounces of flour. Let me measure 12 ounces of flour instead of like 3 cups nicely fluffed up and leveled off. And the same process is true for unmarshalling. And unmarshalling, this is super low allocation here. So this BSON.reader here, that's just a typecast, so that's not doing any allocation. And then we make an iterator, so that's like one little bit of allocation there. We call next, which returns a Boolean and a loop. And we get an element. We actually use the same element each time inside of the loop, so that's only 2 allocations you've done. And as before, like we know what the keys are. We know what we're expecting. We know what these values are. We don't have to like carefully inspect everything to look over and see what it is. So I guess the kind of summation of this is you want to be like Martha Stewart over here, just kind of like scooping flour out and dumping it into a bowl and saying, is that it? Is that it? Is that enough? OK. And not having to kind of fluff the flour up every time to use it. All right, so that's kind of it. That's the kind of baker's journey through the Go driver. We've talked about the Mongo client and the egg and how you can kind of do these 2 operations that Connect does separately. We've talked about options and leavening agents and how powerful options can be in the driver. We've talked about baking from mix versus scratch, which is like how the different flexible ways you can encode and decode your types are. Closing and cooling, which was all about disconnecting your client, and finally weighing your BSON and how the high-performance BSON library can help you. So that's kind of it. I might have time for questions. I'm not sure. There is also a driver's BOF at 4 for the Go driver in Gibson. So if you have questions we can't ask here, you can just join there. And thanks for coming to my talk.
Kris, what's a BOF?
A BOF is a birds of a feather session. It's kind of from the phrase birds of a feather flock together. It's just for like people that are interested in either Go or the Go driver, and you can just come and ask me questions, and I'll answer them for you. We can have a nice conversation.
If you have a question, raise your hand, and I'll bring you the mic. Hold on.
Hi, I'm curious to hear about your experience in working on the Go driver with all the wonderful things, but also limitation that's around Go. For example, not having generics. So I noticed we had to use a lot of interface.
Yeah, that's a particular point of pain with the options design. I think you really just have to sit down and ask, like, how can I flex the language to operate in a way that would give me kind of sort of generic-like functionality, even without generics? A lot of that constraint comes from our specification process, which is kind of heavily leaning toward like languages like Java that do have generics. But I think if you kind of sit down and kind of squint at the specifications and squint at what you're trying to do enough, you can figure out something that's actually tenable. I do think it's very verbose, but I think a lot of that verbosity from things like options falls onto us as the maintainers, and not as much as on you guys, the consumers.
Does the driver do type checking underneath to make
sure
it was passing?
Yeah, so I think that's a part I might have missed there. So there's an interface inside of each of the options package. So if you're doing like a find one, there's a type called find. There's a type in the find.opt package called one, and the find one method will take a variadic slice of find ones. So if you try to pass in something that's not a valid find one method or option, like limit, it will give you a compiler error and your code won't actually work.
Other questions? Here you go.
What are your thoughts on long-running connections? So when your app boots up, create a connection and then create clones, because the current driver that most everybody uses, there's nothing on it, there's no documentation on it, and it actually causes a problem. If you do a clone of a long-running connection and don't close it, it sucks up all your open connections.
Right. So in the beginning, if I can get my slides. So in the first example where I had the connect method, you basically need one client per your entire application per each topology you're connecting to. So if you have a connection string that's pointing at a MongoDB cluster, you make a client and use that client everywhere. It's like a nice Go routine safe thing. We handle all of the connection pooling under the hood. You don't have to worry about any of that.
Yes, hold on.
No problem.
I think you mentioned there was a way to get your document as a map. Is that map from string to empty interface?
Yeah, right now we support map string to empty interface. In the future, we might support map string to some other type, like int or something.
How would you plan on implementing that?
Mostly using reflection. The same way we do map string to empty interface, we do it map to int. And if there's something in the document that's not an int, I mean, that's like a usability thing we'd have to figure out. Like, do we error? Do we just ignore it? I don't know. But it's the same type of reflection. If it's an empty interface, we'll just kind of look at what the type is in BSON and then convert it.
So it would be, so it would be kind of like a map, and then you would call like a method on it to specify the type you want?
I mean, for map string empty interface, we have a set of types that BSON types will map to, like set of Go types that BSON types will map to. And we'll just, if it's an empty interface, we'll just use that type. So like double gets turned into a float 64, and int32 gets turned into int32. So there's, for each BSON type, we have an analogous Go type.
One more question. Who has a good one?
Yeah, so in baking, you can't rush it like by increasing the heat, right? So it's baked when it's baked. When is beta coming out?
Come on, you guys. That was great.
You know, when it's ready.
Do you have a roadmap or feature set that you need to complete?
Yeah, so for beta, what we're talking about doing is trying to do a production-ready beta. So by the time we hit beta, we're like, we've stabilized the APIs. You can now use this in production in your applications. What that really means is that we need to implement the full feature set of all of our driver specifications. And we're a good chunk of way there, but we have some more work to do, so probably not for another few months at the least.